Greetings to you all. My name is Larry Pearson. I'm Vice President of Strategic Client and Partner Relations here at Impetus Technologies. I'd like to welcome you to our event today entitled AI ML Landscape and Applications. Delighted to have you here. Let me just cover a couple of housekeeping items while we're waiting to introduce our speakers and kick this off. You will all be on mute. However, you've got a great opportunity to create some interaction in this event by sending questions in. And we've got time reserved at the end to answer as many of those live and on the air as we can. And those that are not answered here during the broadcast time, we commit that we will send you an email answer to that so that any question that comes in, any and all questions that come in are addressed. And I encourage you very much to participate in that. It's a very interesting part of every one of our events, and we do these with some regular cadence. Let me just take a minute to introduce the other speakers that we have. My colleagues, in particular, Ravi Vallabhojosala is director of our data science practice. Heads that up, is located here in the U.S. and comes to us with 22 years of experience working with customers in the data science field. He'll cover a lot of what we're going to talk about here in terms of landscape and applications, and all of that is born directly out of his work with our clients. So I think you'll find that quite relevant and interesting. Also on the event today is Maxim Skoryov, and he is a senior data scientist who also comes to us with 10 years of working directly with our clients in a lot of these similar applications, and he'll also be sharing some of his experiences. And last but not least, Amit Asudani has more than 14 years working with large clients on the whole area of data flow analytics and a platform which we've called Stream Analytics. He'll tell you more about that. And he is a senior technical architect and leads that practice here in the U.S. Let me take a minute and just walk through our agenda for today. You see that listed here on the screen. For those of you who are not familiar with Impetus, I'll spend just a couple of slides here at the beginning, giving you a little bit of context for who we are as a thought leader, as thought leaders in this space. And then we'll get right into the topic of the landscape and applications for artificial intelligence and machine learning, and cover specific case studies with regard to image analytics, anomaly detection, and optimization in a variety of industrial and energy-related industries. After that, Amit will come on and talk about the self-service data flow and analytics platform and some of our experiences there. And we'll wrap things up, as I mentioned, with a Q&A section at the end, and look forward to seeing your questions and interacting with you on that. Let me just now spend just a couple of slides here to tell you a little bit about Impetus. I've been around Impetus for almost 17 years, and it's been a very invigorating experience as we begin to offer a complete end-to-end solution, which is a mix of services, methodologies, consulting capabilities, experience born in the trenches, and also automation accelerators. And more recently, we've invested a lot of focus on automation accelerators, and we've really got a couple here that you'll see referenced a little bit today. And the first is a modern data platform workload transformation framework, which automates the movement from legacy EDW and ETL environments into a modern data environment, in which in today's world generally means some cloud-related platform. And we are partners with all of the major cloud providers. I talked about the Stream Analytics and our platform for data flow and analytics that Amit will tell you more about. And that, again, is an example of an accelerator. You'll sometimes hear us use the phrase IP-enabled services. So I think one of the benefits of working with Impetus is that we've got a broad range of flexible services IP accelerators, software platforms, etc., to really bring together a heterogeneous set of skills, experience, and IP to help you take the next step in your journey into the modern data architecture. And in particular, one of the great motivations for that is to leverage all of the opportunities that the world of AI and machine learning, deep learning, and related advanced analytical capabilities offers enterprises today. All of that for us is designed to help large complex enterprises create what is commonly referred to as a single source of truth in the enterprise. And that's what we really refer to and call here right out of our mission statement, that we exist to enable the intelligent enterprise based on a unified, clear, and present view of your business. So again, thank you for joining us today. Let's take a look now at a little deeper look at Impetus and who we are. We actually are a group of companies. You see those indicated here on this slide. The core company, everyone that you'll hear speaking today is from this kind of a core company here on the left-hand side, Impetus Technologies. I've talked a little bit about that. We are a U.S. corporation founded in the heart of Silicon Valley, been around in the U.S. now for 25 years, and I'll show you in a minute here a splattering of our customers who represent many of the leaders in the Fortune 250. And we've been privileged to be chosen as a partner to them and helping them in this quest to implement a clear and present view of their business. Kivos is a company that was spun out of Impetus and a result of having earlier, all the way back in 2004, we created a company called Intellicus. Intellicus has a white labeled reporting and BI platform that software companies are able to license and build their reporting and BI module around, highly successful. But as we began to consult and gain more experience with the whole area of big data, and we were an early adopter of big data, actually all the way back to the Apache Hadoop days before distribution vendors and other suppliers were even in existence. We were doing R&D on big data analytics, and that's been some 13 years ago now. But in the course of seeing the opportunity that big data and advanced analytics presented to our Fortune 250 clients, we saw the opportunity to re-engineer the way that BI is done on top of big data. In the past, it has been necessary to pull a lot of very high volumes of data out of Hadoop or other distributed data infrastructure platforms or frameworks in order to do BI, traditional BI, what we at one point were calling cubes on Hadoop, kinds of analytics. And all of that added tremendous latency to that process. So we saw the opportunity to create a way to actually perform those types of analytics directly in the big data environment and avoid all of that data movement. And that ended up being spun out in 2014 as a separate company focused on that, which we call Kivos. And in the course of re-engineering and really reimagining how BI could and should be done in the big data environment, we have been able to deliver patented breakthroughs with regard to very, very low latency on massive amounts of big data in the BI space directly on large data. Lastly, ClearTrail is actually another company which was spun out all the way back in 2004, where we began to apply our analytics and data management thought leadership to the whole space of lawful surveillance. And so various customers or clients of ClearTrail typically would be some country that in their version of a homeland security kind of agency is deploying technology to secure their borders. And that's ClearTrail that does that. So let me just, as I mentioned, give you a quick view of some of our clients. You'll hear during today's webinar various case studies and stories about the successes with regard to AI and ML that we've had with many of these companies. As you look top to bottom and left to right here, you can see, as I mentioned earlier, they are a they're strongly represented by Fortune 250 leaders in a variety of different industries. And so we're pleased to be able to bring that broad perspective into this discussion about advanced artificial intelligence and machine learning. So with that as a little bit of a background on who we are, what I'd like to do now is ask Dr. Ravi to jump in and begin to take us into more of our content with regard to this topic of ML/AI landscape and applications. Ravi, over to you.
Certainly. Thank you very much, Larry. Really appreciate you setting the context for this session, and I really happy to be speaking to all of you today. Thank you for joining this interesting session. The topic, as we called it out, is AI/ML landscape and applications. So I'll take just a brief moment to talk about, in general, artificial intelligence, machine learning, and deep learning, and how they all play into this landscape of opportunities that enterprises are looking at. And to start with, artificial intelligence has been around for a long time now, maybe over 50+ years, right? So dealing with a lot of problems with data and trying to build some systems that kind of mimic human response to taking decisions. So these were the original expert systems and kind of also maybe rule based, but they didn't have the pattern finding ability. So that came in through machine learning maybe around mid-90s, right? So this is kind of like a time when they started looking at how to identify patterns and kind of codify them in algorithms. So we had a lot of ways of kind of creating these algorithms, but a lot of the work with creating those features was very manual, and which means it was easy to go after smaller problems. But over time, it became more and more complex to look at more difficult problems where you have to kind of look at handcrafting features for the problem at hand. And there were breakthroughs in compute and as well as mathematical theories that led to deep learning as a part of general artificial intelligence and machine learning space, where we're looking at now deep neural networks is one kind of such a deep learning approach. They use kind of input layers, and then you have hidden layers and a lot of hidden layers as well as an output layer. So these are actually trained on these days on GPUs as well. So the ability of these deep learning algorithms to kind of create features using representation learning enable a lot of the advances that we see today. With deep learning, it is really caught on, and a lot of enterprises have started building use cases on this, and we are actually very happy to be part of their journeys as well. So we'll cover some of those use cases today, but let me just take a moment to talk about the overall opportunities that we see in this space. So primarily with AI/ML, there's a lot of innovation that's happening around in all kind of areas that you see. It could be with things like Amazon delivering packages to all the way to kind of more simple problems as well. There's a lot of innovation with kind of using machine learning and artificial intelligence. So the way this works is kind of by identifying patterns in really large volumes of data, which means all the enterprises are starting to collect data and have all the data stored that they are using. So the challenge is, of course, making a sense of that data using machine learning systems, and that's where the transition from rule-based learning systems comes in, because in the past, a lot of the machine learning based approaches were built on rules and complex ways of identifying some patterns. So you see something changing, you write basically a rule for it, and that rule kind of captures it, and that kind of leads to complexity because it's hard to scale those rules for all kinds of scenarios. So that is slowly transitioning into learning systems where AI/ML coming to have a significant role. Of course, this is leading to more productivity because of the automation that's involved, and being able to kind of quickly respond to various situations that may arise and scenarios that were not anticipated before. And in some instances, it's also relevant for customer satisfaction because you're able to quickly respond to customer situations where traditional rule-based systems will be difficult to capture. So you can actually figure out what the intent of the customer when they're calling into call center and try to respond to that, much quicker than earlier. So that leads to customer satisfaction. And all this automation is also helping lower the operational costs, because that's a key part of the ROI on AML for enterprises. So this is a small graphic I included here from impact and Statista. So primarily the core idea to communicate is that businesses are using AML to kind of derive innovation from data. But of course, it's all about competition on the core collection of data, not only just maintaining the data, but also having a strategy around, managing all the data stores, the data lakes or data warehouses, and all the data that can be made available for analytics and machine learning applications. So using all of that data as an asset is another aspect. So as you can see, there are multiple pieces of this, all relating to data and various things that are very relevant for driving the business outcomes by adopting AML. And definitely some enterprises are better in driving this transition. And those are enterprises that you see really leading the transition from a rule-based system to a more AML-driven, data-driven and AML ready enterprise. So as part of that, we have been very fortunate to kind of work through a lot of use cases with many customers of ours in many industries. And these are just a sprinkling of those kind of examples. With you can see some case studies we can cover with the data analytics and modeling, where we can look at descriptive, prescriptive, and predictive and prescriptive analytics, or we look at anomaly and fraud detection as a example of this. There's also text mining, natural language processing space, where we do a lot of work in customers on sentiment analysis or identifying topics, or even customer feedback analysis, which can drive the customer reviews and try to identify problems with customer satisfaction. Document summarization is another big area where we're looking at kind of improving ways that a large amount of documents can be consumed quickly. There is also image analytics, which is a really big part of what we do in terms of being able to digitize documents and extract information from those documents. And these could be things like, traditional, spreadsheet documents, or there could be more complex PDFs where you have also what are called PNIDs, which are piping and instrumentation diagrams that oil and gas industry uses. Also medical images and various other kind of images such as patient forms, where you can extract information. Another example is receipts from all the expenses that employees make purchases on. So identifying and validating those receipts expenses is also another area. So there are multiple use cases we actually have contributed to. Then voice analytics and conversational AI is another space where a lot of areas with intent detection and identifying the speakers and converting speech to text and everything that feeds into chatbots, and trying to kind of proactively kind of figure out what the customer is trying to speak, and also their emotion, and try to take all of that into account and kind of come out with a decision that could be taken quickly. So you reduce the throughput time for that call and increase the number of calls you can handle in the call center. Infrastructure cybersecurity is another space where we have worked with customers in a lot of areas with monitoring various kind of attacks, or kind of figuring out how to kind of forecast potential demand that can arise, and also utilities that have power and power surges. How do you anticipate that? How do you kind of also help with bidding, enabling them to automate the bidding process? Because in deregulated markets, that as in US, the power is actually a something that if you're generating power, you have to compete with others who are generating power as well. So the bidding is very important. So in order to win, there is approaches that these enterprises use. So we'll talk more about that in a specific use case in the later section or later part of this session. And there's also equipment monitoring and things like condition monitoring and predictive maintenance that come in here as well. So there's a lot of work we do in this space. And lastly, on this slide, I'll also briefly touch upon how we are using AI with our customers on a lot of sales and marketing use cases, with many specific use cases such as lead scoring, recommendations, cross-sell, upsell, various other use cases such as what action to take next, the next best action or best time to call for a sales representative. How do you even schedule their calendars to kind of call prospects and be more effective at conversion? So this is just a small sample of the work you do. There's a lot more things apart from this that I showcased here. But just to give you an example of that, the broader landscape of use cases is vast, much more vaster. There's a lot more areas that all the enterprises are maybe interested in. We are in a lot of these use cases that I show on the screen here with healthcare to log analytics to anomaly detection and energy utilities or more logistics planning. It's a broader spectrum of things, and there's a lot more that I've not included as well that we are also part of. But the landscape continues to grow as more and more enterprises kind of start realizing that their data is the critical asset, and they can start building use cases around that to kind of derive business value and be able to more retain customers as well as innovate and develop their own products and solutions. So coming down to our data science practice at Impetus, we essentially work with global customers across many sectors, as I pointed out earlier. We are involved in a lot of advisory, implementation, support services and solutions with these customers, as well as on internal R&D that we do. So a lot of data analytics, science analytics, and engineering skill set in the teams that we work with, primarily around a lot of open source tools and technology capabilities, as well as cloud experience and specifically cloud ML capabilities. So a lot of things that we do with, as I mentioned, built around open source tools. So we have our own accelerators that Larry talked about. So all of these are kind of enabling our customers to derive value from the data and be successful in providing solutions to their own customers. So as part of this, the key aspect to kind of consider is how do we take all the data that our customers in multiple sectors are looking at. So this data tends to be of multiple types. One is structured data or semi-structured, unstructured data, and each of these has specific characteristics. But the data may vary from sector to sector. The kind of data they have, the labeling that they do, or if there's no labeling, how do they manage that? So this can vary from as I point out. This can be banking customers or insurance or communication and so forth. There's a lot of customers, and specifically we can also talk about some of these customers that I'll showcase some use cases around in a few slides later. But primarily the way you deal with these three different kinds of data sets will differ, primarily because they all feed into the insight generation pipeline. Essentially, you have a way of taking this data, analyzing it, bringing it into your data processing and analytics workflows to kind of create the capability of generating insights. And in order for you to do that, you need to be able to kind of deploy data analytics, machine learning algorithms, or artificial intelligence algorithms that understand how understand and identify the patterns in these data sets, kind of apply specific algorithms to kind of generate those insights. And that may vary based on the use cases that you may be looking at. Could be natural language processing or image analytics or others. So it all varies. The insight generation is an entire workflow in itself, which I'll briefly touch upon, which is primarily journey from your data. On the left hand side, you see there's historical data sets and other maybe third party that's data such as weather that may be coming in. All that feeds into the data warehouse or data lake, where there's a lot of data engineering, plumbing, and kind of being able to extract the data, populate the tables, maintain the data quality, do feed monitoring of these data sets. There's also metadata involved, management involved, because in order for your data to be used by the machine learning algorithms, there's a lot of curation that needs to be done so your data quality is high. So the algorithms that can do better job. So the data science that you see at the middle of this image is kind of built around data exploration and modeling with the artificial intelligence and machine learning capabilities, where you're looking at kind of building algorithms for either predictive analytics, prescriptive, or various other specific customer use cases like customer experience, marketing, sales. It would depend on what kind of use case you want to pick up. But the core aspect of this is the iterative process of continuously building models, training and testing, validating them to be able to have confidence in prototypes that you're building. Now, the next level is to, of course, to scale these prototypes and be able to take them to production, where you are essentially building, applications around these prototypes that scale on Spark or, other. They may be containerized with REST APIs and be able to serve those out. And there's inference that happens where the actual containerized model or application is actually in a accessible for the end user in an app where they are basically, let's say they're clicking an image or something and that image is classified as a specific object, and otherwise it's misclassified, then that data can be fed back as well. There's a feedback that can happen and that comes back to the data sources where that's used for retraining and improving the performance over time. So this iterative process is kind of the common to all enterprises for employing AI/ML, and that's what kind of drives a lot of innovation in each of these buckets that you see here. There are various detailed processes which are kind of gleaned over, but there's a lot of things underneath this to kind of make this whole thing work seamlessly. And there are various teams, could be just pure data engineers, could be data scientists, it could be ML engineers, or even DevOps engineers and machine learning engineers, and all these kind of people overall work together. And there are scenarios leading us to into ML ops and other areas that kind of enable this whole end-to-end process in enterprises today. And that's why a lot of innovation is happening. And we see some of that through the what we call Impetus scalable data science methodology. This is a kind of a approach that we deploy for the data science use cases where we are kind of analyzing data. We actually, even before we get to the data, we interact with the business to kind of understand the business problem. So a lot of business understanding is critical to the data gathering and understanding, because that drives a lot of the processes downstream, where you're now starting to look at data preparation, getting data samples, or creating various modules for that will become prototypes. So ideally, you're kind of iterating over this process of building a model and evaluating it and improving performance as you are gathering more data and improving your understanding as well. So as this happens, and you're building prototypes. So the prototypes are now ready at a stage where you can take them to the next stage of scaling them. So that goes through working, taking a non-scalable algorithm that you have built, or to a more scalable algorithm, which is starting to kind of look more and more stable. And you kind of start building an application around it, and then also evaluate it in production and then deploy it. Not only that, you're also doing monitoring and kind of trying to figure out various aspects with the model and the data that's flowing the production systems. There are various aspects, including data, the drift monitoring and production management as well as this, that come in. But this end-to-end process and that feeds back on itself as new data is collected and it's used to improve the algorithms, as I mentioned in the last slide. That's all part of this process, and the tools we use may vary in each stage and depending on the skill set of the teams that are using it. Like I mentioned, the data engineers or data scientists and ML engineers and so forth. So by and large, this is a rigorous process that we use to kind of enable that the specific data science engagement we're working with a customer, or an internal engagement or a product or solution we're creating, is very successful. So I'll skip to the next part of the section where I kind of want to talk about infrastructure, the issues that are that we're seeing today with a lot of the infrastructure that is around the country, right? So there's a lot of concern around aging infrastructure, primarily because all of this infrastructure was built a long time back and maintenance is an issue. So in fact, this year, ASCE, which is American Society of Civil Engineers, has put out a 2021 report card for the country's infrastructure, covering a large number of areas, right, from aviation to bridges to dams and so forth. And this is just a piece of information I've taken from their report, annual report. So there are various issues with all of these areas, and the overall grade that ASCE has given out is a C-, which is pretty low, and partly because of the way all this infrastructure is being managed, and the people, process, technology that's part of this whole system is kind of like a little out of date, and that has to be updated and made more modern to kind of be able to kind of identify problems faster, quicker, fix them sooner, so that the infrastructure can be more efficient. And if you take specific use cases, for example, in each of these areas, you can look at, for example, there are use cases specific to those areas. We can actually look at as areas where AML can have a role. Take look at aviation, flight maintenance, and even airport operations. A lot of things, bridges. We have seen them fail. So failure probability predicting that is a big problem. So how do you collect data to be able to predict that kind of scenarios? There are things with dams, energy systems, various other things that are very relevant, and I've captured some use cases that may be relevant here. But if you look at how AML can contribute here, there are things around applying time series analysis or anomaly detection or forecasting or specific ways you can resolve the issues and build capabilities around maintaining these aging infrastructure assets, right? So to enable you to do that, we wanted to focus on one specific use case, which is what is called PNID digitization in the energy industry. So PNIDs are a form of asset that oil and gas industries have in like thousands, or if you collectively look at the entire oil and gas industries, in millions of PNID diagrams. So these are essentially piping and instrumentation diagrams, which I'll talk about digitizing and how we apply AML to this task. So this is what we call document digitization with image analytics. So basically, how do we apply image analytics to take a complex representation of a oil and gas, let's say a processing plant or a refinery. There are multiple processes running in the system, and these are all represented through what are called piping and instrumentation diagrams. So all the piping you see in this graphic here is actually schematics, which is like you can think of them as schematic drawings of which are representative of the actual process. That's what engineers use to kind of understand and figure out how various processes are connected and where all the instrumentation is, and how do you kind of extract information from that. So the biggest challenge with these PNIDs is being able to make sense of them, primarily because they're highly complex drawings. And also the data that they use is in very proprietary formats, and it's often needed for financial calculations and their internal audits, which are required. So they may require a bill of materials, or also to make all these objects that are in the diagrams searchable, because it's manually very difficult for someone to go into the process plan and take a list of all of the equipment they see, because that's a laborious process. So they actually have these PNID diagrams that all the engineers with a lot of experience can quickly refer to, and come back with a specific wall that they find on location, how to kind of use a different wall for different application and so forth. Now, of course, these drawings are used again and again. Oftentimes they're either paper based or in AutoCAD drawings, which are not digitized. So searching through them is a very laborious process. And also, even if they are in paper copies, they're scanned, and the scanned copies are have issues because they are used by OCR to extract information, which is the optical character recognition. So out of box OCR will have a low performance with these kind of PNIDs, partly because they are often low resolution. They have font and size orientation variations. So a lot of this is a simple PNID representative graphic, but in reality they can have like hundreds or thousands of instruments on one diagram, which becomes really difficult to read and process. So, and they can have various fonts and sizes, and you have to be able to detect these in different orientations as well. Also, when you're scanning the image, there can be issues with contrast and exposure and various other technical aspects involved. There can be objects that are embedded within the images, and there are how you have to be able to detect them. So it all depends on the context of that specific instrument, and there's text around the instrument as well. So you have to be able to detect those. So it's not easy to do this, using traditional techniques. So we created a entire end-to-end workflow using deep learning algorithms to kind of extract this information. from PNID diagrams for a customer. And the way we did this was applied, image analytics algorithms that are built on convolutional neural networks and variations of that. But also we augmented the data set, training data set, and to ensure that any variation of the data can be detected. So ultimately, we are able to kind of train this algorithm to extract information from these images and then put all of the data into Solr to be able to make them searchable. So as you can see from these small images here, the algorithm detects the labels, the characters that are within these symbols, different kinds of symbols. But we have our proprietary approach to kind of group together different contiguous characters, because there may be issues with adjacent characters because you're not sure which label they're part of. So we kind of proprietary had created algorithm to kind of extract that logic. And the figure that you see at the bottom is something that generates these labels. So those are the labels we are able to identify and number them. So we can actually now start populating a database with all of these labels, and they're associated with specific symbols. So extracting those symbols and instrumentation is also the next task, which we were able to do. Here's an example of some of the equipment we kind of extracted. Look at different kind of walls and piping and instrumentation. So these are all we can identify based on the specific characteristics. And as I mentioned early on in the initial stages, the advantage of doing this is you did not have to manually say a wall looks like this, or a pipeline looks like this. The system is on seeing a lot of these data sets, data kind of figures out the relationships between the pixels, and that's how we are able to identify these. And secondly, when we look at the benefits that arise out of this kind of approach, obviously the oil and gas industry has lots of these kind of images that are used across the board in various applications. Could be downstream, upstream, midstream. So you can essentially make a significant impact by digitizing these documents and enabling them to be able to kind of search quickly for any equipment that they may have. This could help them with safety response and also equipment management and managing inventories and so forth. Also, of course, you can look at creating in-depth plant operations. In fact, bringing cognitive capabilities to the plant operations is a really happening thing, because all the enterprises that are in this space would like to get to a place where they can actually operate these plants by virtually, by being able to see those through cameras and being able to track various equipment. So recognizing these equipment is very important. Then similar kind of things can be applied to other kind of documents in other industries. You can think of electrical diagrams, or architecture floor plans, or various other kind of documents. Wherever you have this kind of structural relationship between various components, the same approach should be applicable. So we are essentially this is kind of an accelerator we can apply to those kind of data sets and help those customers to be successful. So this was one of the use cases I wanted to talk about that we were successful in delivering to this customer. Another use case I will also talk about is out of pattern transaction. This is an important case study for us, primarily because of the way we were able to help our one of our strategic partners. So this is a customer we've been working with for many years, over 10 years and so forth. So they have they're in the financial space of providing credit cards both to corporate customers as well as individual card customers. If you look at corporate cards, unlike personal credit cards, have specific requirements because they are managed by the corporate card owner. So let's say the customer gives out corporate cards to one of its clients, and that client has a lot of employees who use corporate cards, who have spending limits as well as limitations on what they can buy. So the idea is to be able to detect these out of pattern transactions, which are not necessarily fraudulent transactions. They're just out of pattern, unusual changes that you did not anticipate. And these kind of unusual changes are not restricted to financial industry. They are also part of use cases you'll see in across multiple sectors. I just gave an example of financial sector because that's something we worked with, but we work with a lot of customers also in areas in banking to telecom and networking and various other areas. And these are some of the use cases that are common. It could be to detect abnormally high purchases, could be indicative of a money laundering operation or something like that in banking, or it could be a roaming abuse in telecom and so forth. And this is a kind of like a sampling of these kind of examples that you can see. And the anomaly detection is common to pretty much all sectors. There can be various scenarios that you can treat as normal, and then anything that deviates from that you would like to capture so that you can investigate further and figure out if that's something that's allowed or there is something that you need to respond to. In the case of personalized credit cards, that becomes a serious issue because you want to be able to respond immediately and stop the fraud from happening. In the case of corporate cards, it's a little more nuanced because the idea is to be able to increase the spend that the customers do, but at the same time not restrict them from spending, but be able to manage how they spend on things that they're not allowed to. Like, for example, if you're going out to buy wine at lunch, that may not be allowed by the specific company policy. So the employees have to adhere to the company policies. So the overall spend by these employees may vary over the week and day and month, but by and large, we see a lot of patterns in the way this data is collected by the card providing agency. So the customer actually was looking for a solution to monitor these unusual transactions, primarily because they were kind of be unable to do so because of a solution that they had that was not scaling, because that had issues with the way it was architected. So we were able to kind of look at creating a new approach. The primary challenge in kind of tackling this problem was to be able to scale that model for detecting these outer patterns to the entire middle market, which is 2 million card accounts that they had. And there are a lot of card holders who are spending in over 10,000 different industry categories. Like I could go spend, example, at office supplies, or I could be buying, other things that may be required, or I could be, using it for taking a lunch client out for lunch and so forth, right? So there are various sectors that I could be spending on. Now, these corporate cards also have rewards associated with them. So you have to be able to figure out the points to award to these customers based on where they're spending. So you have to be able to kind of tease out the merchant that are spending it, and also be able to kind of look at all these different industry categories. So it becomes a really high dimensional problem to tackle. So the solution that they had in place that they were planning to use was not scaling because of this exact problem of high dimensionality. And this graphic here gives you an example of why this is relevant, because generally the spend across cards can vary based on the number of the amount of the age of the spender and so forth, and it can vary on the location as well. But overall, by and large, it can have an impact on the spend. Now, the solution that we created primarily took all this data into account. There's over a billion records that we would use to kind of build these. So we kind of created clusters of individuals, corporate card members spending at different merchants, and we extracted various features and applied unsupervised learning to this problem. In addition, we were also looking at identifying card members that are spending similarly using peer sets, which is a very critical problem in this space. So the approach kind of used the unsupervised learning to kind of identify and build. With this model that we built, was able to score new transactions that are landing in for being out of pattern. So this overall end-to-end process was something that was very successful, and we were able to scale this out and productionize this model because that helped them kind of get over the roadblock of not being able to use an existing model that they had. So from a benefits point of view, there are a lot of positives from this experience with this customer, where we were actually looking at scaling the model to their entire middle market of 2 million card accounts. And the overall speed up we obtained was 50 times what was possible earlier. So they could actually run this faster and more times. And whereas the previous solution was not able to scale beyond a few thousand card members. And also this same problem, same approach could be extensible to the small and medium business and large market use cases, which is in another revenue-based classification that they have. And the approach also identifies, prospects for other added services, because as this card or the card members are spending at different merchants, they essentially can be identified for promotions for various other categories and so forth. So the high spenders that you're identifying can actually potentially be customers for another business within the same organization. Then again, model scoring, similar kind of thing can be enabled in real time or near real time. So in case you want to be able to detect out of pattern spending more faster, you could also do this more effectively by doing real time scoring. So we have a specific tool for this purpose, which my colleague Amit will be talking about later in the session. But I just wanted to mention that here. And the next one I want to talk about briefly is identifying paint defects in auto manufacturing. So paint defects is something that's very critical for the auto manufacturing industry, primarily because the car, as it's being manufactured, has to be painted. The auto body has to be painted, but painting is a laborious process, and you want to minimize the defects as much as possible. Otherwise, you would have to take the car back to your starting of the paint shop. The paint shop is a complex operation where it has primarily it's an enclosed space where they control the temperature, humidity, the voltage of all the tools, as well as the robots that are spraying the auto body. They have to the motor speeds have to be controlled as well, and it would depend on which part of the car body, auto body is spraying, because the different kind of paint applications you would have to apply. And overall, the metric they use to detect the defects is something called defects per vehicle, is DPV, which is primarily a measure of how good the painting process has been. So suboptimal conditions will increase this measure. The idea is to be able to apply machine learning to reduce this DPV as much as possible. Otherwise, some defects, which we call fatal defects, will require you to take the vehicle back for repainting, and that will lead to loss of revenue. And this was a leading auto manufacturer in the global manufacturer that we were working with, one of the luxury line of vehicles. So they had paint problems, and they wanted to avoid all the hassle of being able to deal with paint problems later when the vehicle actually is in the dealer lot. Then it becomes a very bigger problem to deal with. So the idea is to optimize the paint shop conditions and advise the plant managers to lower the DPV as the painting is going on. As I mentioned, the painting is a very complex process, so you want to be able to manage this very fine manner. So there are over 45 steps, and there are a number of tasks, and for multiple layers you would apply, and it takes over 10 hours to do this whole process end to end. There's also various physical conditions, the temperature, humidity, and dust that's in the paint shop you have to be minimized. So obviously this is a complex operation that requires very so it's hard to do manually. You cannot kind of change a setting in one location, because that will have impact in other locations in the paint shop. So the way we did this is we applied machine learning algorithms, in this case random forest classifier, to figure out where all the defects were happening on the auto body, different components, and then used genetic algorithms as a optimizer to kind of figure out which parameters to control to lower the defects that are arising in each of these. As you can see, the door has the biggest number of defects, and you would not like any paint defects on your door. So how do you kind of reduce that? So the genetic algorithms helped us kind of create the optimal combination of physical conditions that minimize the DPV. And the other advantage of doing this solution is we enabled a interpretable way of creating the model recommendations, so that you could actually say, okay, step by step, do this, do this, do this. So that will lead to your lowest DPV possible. And this actually was very effective, because it saved them over hundreds of millions of dollars for the customer. And lowered the DPV from 10 to 5, which is still significantly lower than what they would have been be able to accomplish manually. And this interpreter approach helped reduce and improve customer satisfaction as well. So these are a number of use cases and case studies I wanted to cover where we applied AML, and this last one is an optimization use case. But optimization is used in more generic fashion in a lot of other industries, and I'll actually request my colleague Dr. Maxim Shkaryev to come in to talk about an optimization use case that he was part of, where we worked with an energy customer to help them kind of optimize the bidding patterns and so forth. So let me stop here and maybe Maxim can take over from here. Max, over to you.
Yes, thank you, Ravi. Thanks all for joining us. My name is Max Shkaryev, and I would like to tell you about the work our team has done on bidding optimization. So companies selling their product or services or buying material for needed for the production, they'll participate in some form of bargaining in order to establish a price. So an auction is an example of such a bargaining, where traders will propose the price for an item, and the lowest and the price satisfying the demand will be identified. So the issue that the traders will face is the complexity of the environment where bargaining is taking place. So furthermore, not all the information is going to be available, right? So a lot of the information is proprietary, and therefore there's this additional challenge of often learning from partial information. So our team has worked on 2 case studies where our clients aim to automate the traders' decision-making while coming up with a bid. So we consider the history of the bidding, as well as other important factors to develop machine learning models capable of coming up with an optimal bid under the specific circumstances. And I will tell you about the 2 case studies that we did, one for electric power generators, and the work we're doing right now for food retailers. So a large part of US electricity market is set up as an auction that is regulated and controlled by an independent system operator or a regional transmission organization. So the power generators will bring to the market hourly proposal for the power to be generated, and the distributors will provide the request for the expected consumption of the energy over the same period. So basically, the generators represent the supply end of things, while the load represents the demand, and the ISO, the independent system operator, combines the supply and demand information, identifying the market price and informing participants of the outcome. So we're modeling the behavior of the traders from the generation of electricity end of things. So the generators must provide a combination of bidding quantities, so price that they will enter the auction, and the quantity. So so essentially, the traders are solving this problem of bidding high enough to increase the potential profit, while trying not to exceed the price to be identified by ISO, so as to win the bid. And of course, the challenge of such a task is due to high complexity of the environment where this decision is to be made. Right. So in addition to weather, fuel prices, and competitors' bids, the traders they will take into account challenges posed by the transmission, constraints by laws. So essentially, when establishing the price, and this task is certainly achievable by machine learning algorithms, while incorporating, taking into account high-dimensional data may be unachievable by, or at least to the higher to the same level of efficiency is probably not efficient, not achievable by human traders. So the generators will provide two bids. Right? They'll provide the bid in a so-called day-ahead market and a real-time market. So the idea here is that the real-time market is perfectly inelastic, and the distributors must provide that is the distributors must provide the exactly as much energy as it is requested by the consumer. Otherwise, you'll have a blackout, right? So in order to reduce the price volatility, the day-ahead market is set up so that you can sell. You can essentially assure availability of a large part of the requested energy before this the market becomes perfectly inelastic. So that that is essentially what's illustrated in these two figures. Is what schematically, at least, what the supply and demand would look like for those two cases. So the model that we come up is expected to come up is expected to generate four quantities, two quantities so price and the amount of the volume of the power to be generated for the day-ahead market and for the real-time market. So the energy demand, and is largely dependent on weather. So think of AC units running when it's really hot and heating running when it's cold, right? So that's that. So the weather is gonna be a strong presence in determining what the demand curve will look like. The energy supply is primarily affected, and particularly for our customer, would particularly be affected by fuel price, and so gas in our case, and bidding choices of the competing generators. All right, this is one of the bigger challenges. Is really you are participating in an auction with other traders, and the ability to predict what they will do given the same circumstances is crucial, right? So basically, just to reiterate, predicting the optimal bid requires a model to capture all of these features of the supply and demand curves. So we build our solution based on a multi-agent reinforcement learning model, schematically presented here. So essentially, each trader here is represented as an agent, and the different agents are interacting with each other, attempting while participating in an auction, with a goal, of course, individual goal to optimize their own profits. So each agent so we model each agent as having a bidding policy that they're trying to learn. And the policy here is basically a probability distribution conditioned on state of the environment, that is weather, fuel prices, and importantly, of course, the history of the bids, whatever is available to you. So your own bids, the success of your own bids, as well as whatever information you have regarding. Perfect. 1 second. I'm not sure if you guys can hear me. So whatever information. So essentially, whatever information you have regarding the bids of the other agents. So each agent is attempting to optimize their policy using a policy gradient algorithm.
Looks like Max audio is frozen. Max, are you able to hear us?
I can hear you. Can you guys hear me?
Yeah, we can hear you.
Okay,
Please
I
continue.
can't see the
video is frozen.
Okay, yeah, I think the video is frozen. That's the problem. Okay, essentially, so let me tell you about the what we got as a result. So the solution, again, the solution that we built generated 4 quantities for each bid, right? So the amount of power to be generated and the price, both days, so for both the day ahead and the real-time markets. And we showed that the solution, in fact, converged to the analytical in a simulated environment. And interestingly, we actually saw collusion-like behavior under certain conditions, which is in fact that is in fact something that would be prohibited by ISO, and it is something that is an additional challenge that was well, in the future would have had to been addressed. So another use case, another case study that I would like to tell you about. This is something that we're currently working on. It's a similar problem that retailers face when trying to place their product on a shelf in a, let's say, grocery store, right? So the retailers will bid on a placement of their product on the shelf, right? And will compete for different positions depending on where they think is they want their product to be sitting. The idea there is that of course some positions on the shelf are more preferable. So think the items that are at the eye level would be more likely to be purchased, while you know, items that are sitting below or above the eye level, they might be less likely to be purchased. So the parameters that we're considering here are items' likelihood to be purchased as a function of as dependent on position on the shelf, right? So that is one of the sort of the bigger challenges there, but of course at the same time factors like the location of the store will affect on where what kind of preference your particular item will see, as well as season may have an effect on whether on the popularity of a particular item. And just as in the electrical power bidding, the history of the past bids will play an important role in since again you're competing against other agents that perhaps are trying to place their items on the same spot on the shelf. So clearly there's a clear need. There's a clear need for automation here, as the landscape is is definitely very complex, and human agents can benefit from at the very least assistance with their decision with the machine learning approach that can take care of can consider all the complexities of the bidding environment. Next slide, please. So our approach again here was it's a similar approach. It's based on multi-agent reinforcement learning model. The model here generates a combination of the bid and the shelf position, right? So essentially, you have this output that's that recommends on which position. Well, it essentially can be treated as a recommendation to where your bid should be focused on. If you have limits on, if you have a sort of limiting conditions on how many bids you can place. And the policy here is basically, again, similarly learned by a policy gradient algorithm. So ultimately, the recommendations that come out of the model, out of the solution, can help the retailers to optimize the product placement on the shelf, while optimizing the overall profit. So bid automation, so the process of bidding automation provides better performance. It enables the traders to come up with a more optimal bid by considering these high-dimensional factors like weather, fuel prices, or shelf layout that I've mentioned for these two use cases. And of course, what they have in common is behavior of the individual other actors, other agents. And again, the ML solution is able to make these predictions across the high complexity environment that's typically not going to be available for the human agents. And generally speaking, it's also it is of course able to continuously be updated in response to whatever other agents are doing, to however market responds to your product. And it's this continuous updating of your model is available as a solution. So there's a solution available through Impetus that in fact enables you to build these models in this changing and update them in changing environment called Stream Analytics. And I would like to invite our colleague Amit to tell you more about it.
Amit, you're on mute.
Oh, sorry for that. Thank you, Ravi and Max, for sharing your insights on emerging use cases and patterns in AI and ML space. AI and ML is changing the world for better. This is indeed an exciting time to be alive and watching the magic unfold. Now, as I understand, it takes immense amount of data crunching skills and scientific methods to realize the insights and use cases like the ones shared by Ravi and Max. We have seen data scientists and engineers spending significant, I would say, more than 60% of their time on setting up and navigating the myriad number of tools, utilities, version compatibility among those, data prep and quality and cleansing, transforming it to be usable for machine learning, worrying about scalability, governance, and deployment on complex web of environments. This has become a huge deterrent in adoption and market rollout of ML implementations. This wears down the energy and productivity of teams, which could have been used to solve the use cases and generate insights. We believe Stream Analytics is one-stop shop answer to this. I will walk you through what capabilities Stream Analytics platform offers to build, operationalize, and manage machine learning models at scale. This particular slide highlights the focus areas of Stream Analytics. The first one is self-service. Stream Analytics offers graphical and very intuitive visual canvas where you can drag and drop operators and build out an entire machine learning lifecycle visually. Next is Data 360. This is the word we have kind of coined. We believe that any kind of data processing needs you may have, whether it is batch, micro batch, near real time, or pure streaming, everything can be served using the Stream Analytics interface. We have a range of most commonly used connectors with which we can connect to data sources such as Kafka, JDBC, S3, be it on premises or cloud, both. We have more than 300 plus ETL functions and ready to use ML functions, which can help you build all machine learning pipelines in very easy and intuitive manner. And all of this comes together with a robust metadata management and lineage capabilities. The next one is the change data capture. This is a very, very common use case that we see with our enterprises. Essentially, what it means is capturing the changes in your OLTP databases as they happen and move them to the target sinks in near real time. CDC comes in very useful application when you want to either create a new data lake or migrate data from one environment to another, or for that matter, move data from on-premises to the cloud. The next one is machine learning. We offer a platform where entire machine learning lifecycle is played on Steam Analytics, right from data discovery to feature engineering, trying out different data science models, performing A/B testing. All of that happens on the platform. We support various different machine learning languages. You can bring in your own machine learning algorithms or build it on and design it on Steam Analytics. For that, you can leverage R, Python, H2O, TensorFlow, Spark ML, any of these different languages for building your model. And once you have built and trained the model, you also have capabilities of deploying this model and do all sorts of model operationalization. For example, you deploy a model for training or prediction, and as time progresses, you may want to understand how your model is performing. Is model prediction deteriorating, or is it giving the same accuracy as per the original version of the model? All these kind of capabilities are built into Steam Analytics, which help you determine how frequently you should retrain your model, what kind of emerging data sets or patterns there are, which can help you determine whether the model needs tuning or retraining. So Steam Analytics gives you all of those insights into your model. And lastly, monitoring and DevOps. Even though you may design your machine learning pipelines, be it training or scoring, one of the most important aspects is how do you ensure these pipelines keep running in production day in, day out and do exactly what they are expected to do. And in case of failures or errors, is there a way Steam Analytics can potentially resume those functionalities by itself? We call this self-healing pipelines, and we can automatically recover from certain issues and failures. The one key thing I want to emphasize on this slide is the extensibility feature. While we do offer a self-service UI where users create all these machine learning pipelines, data processing pipelines in an easy drag and drop manner, we also do understand that enterprises will have far more complex needs where there will be requirements to inject your own piece of logic. It could be any proprietary piece of algorithm or model that you want to embed. Steam Analytics supports Python, Scala, Java. You can literally have your code written in any of these languages and embed in any of these pipelines. The whole intent is you focus on your business intent. You don't have to worry about how to glue it into the Steam Analytics or how to run it in a scalable and a distributable fashion. Next slide, please. Steam Analytics can be deployed on-prem, cloud, or hybrid way. It offers a strong cloud ecosystem. You build on-premises or cloud applications that connect to infrastructure components and services no matter where they are. Steam Analytics also have a light version. Steam Analytics Lite is a free, compact version of the Steam Analytics platform. We are also launching Steam Analytics SaaS version. This will further cut down any barriers, and you could literally get started in times of minutes instead of days. Next slide, please. Like I said before, ML enablement is a core focus area for us. Steam Analytics is an evolved, feature-complete bundle and empowers teams with the unified platform with everything you would expect in an enterprise-grade data and ML platform. Please. This is a complete overview of entire data science lifecycle. You have all different kinds of sources from which you may want to ingest, acquire your data. And once you acquire your data, Steam Analytics helps you in all different stages from data preparation to feature engineering to machine learning and model building. And this is an iterative process where you keep preparing your data, you work with different kind of models, different versions, different parameters. So you keep doing this in an iterative manner. And once you are happy with a particular model or set of models, or maybe some particular versions of the models, you can deploy those. And those models can be deployed either as independent REST service or as an operator which can be used in multiple stream analytics pipelines, be it a batch pipeline or be it a real-time streaming pipelines. This is a similar representation of the previous slide. In this, I have broken it into 3 stages and show how individual entities within stream analytics help you in different stages of entire machine learning lifecycle. Stream analytics also support usage of familiar IDE tools like Jupyter Notebooks for development and exploration. The IDEs are deep integrated with the rest of the platform, like registering and using models developed in the Jupyter lab and integrated with the pipelines which are running in the stream analytics. We support hot swapping, so the currently running pipelines in production need not to be recreated or restarted. We can swap the models while the pipelines are running, ensuring no data loss and up-to-date accuracy. Right. This is one of the screens I have captured to show how users can build and configure machine learning pipelines in Stream Analytics Web Studio using readily available ML operators. I would invite you to visit Stream Analytics website for more details and also explore Stream Analytics hands-on. We have been featured in streaming analytics reports by leading research agencies such as Forrester and Bloor Research, to name a few. Stream Analytics is powering high-demand real-time and batch analytics in very large enterprises in financial, healthcare, telecom, and industrial automation sectors. Looking forward to see you also to take advantage of this platform and realize massive productivity gains for the data science and analyst community in your organization. With this, I will again invite Larry to take this session forward.
Great. Thank you so much to our experts today to take us through a broad view, just to summarize some of what I hope you're taking away from today's experience, and that is that we are 100% specialized and focused on enabling powerful and intelligent enterprises, and we do this by helping to build data or deep data awareness through data integration and advanced data analytics, which has been the topic of our interaction today. One of the things that I had emphasized at the closing, and hopefully you've seen some proof points of that here as we went through the material, is the fact that we have a rich set of heterogeneous skills, platforms, accelerators, software tools, a complete slate in our data engineering and our data science practice, whether it is skills with regard to data prep, data blending, ETL engineers, or ML engineers and data scientists, and as well have partnerships and skills out of our cloud practice to ensure that the models you're deploying are deployed and optimized in a cloud native format, regardless of which public cloud platform you may be wanting to deploy on. And lastly, we've got a complete practice also on the whole area of DevOps for all of that as well. So hopefully that came across in today's conversation. You will have the capability to follow up with us by reaching out to us with a simple email at inquiry@impetus.com. And in addition, we've got a nice smattering of questions which have come in during the event, and we'd like now to focus on the time we've set aside to be able to answer those questions. And I've got the whole panel here to call on, and let me first ask Ravi to jump in. There's a question here, Ravi, that says, what are the technologies used for data science workflows, that we referenced and talked about here? If you could talk to that.
Certainly, Larry, thank you very much, and thanks for the question. The data science workflows are primarily built around the core Python and R, because that's what a lot of the model prototyping is done. But that's just a model development lifecycle part of it, right? So we do data exploration. For that, we need the data. So to extract the data, we use SQL, or we have to do Hive queries if you're extracting big data store. So we can actually pull the data, and then on the data we do data exploration. As part of that, we use R and Python, primarily to build a prototype and test our hypothesis. There's a lot of hypothesis testing that's done as part of this as well. So once we have a prototype we can build with R or Python, then we can now take it and scale it out using the broader scale frameworks that help us take the models to production. And there we have to deal with the kind of either containerizing this model or converting it to PySpark or being able to kind of run it on Spark and so forth. So by and large, it's two parts to this puzzle, right? One is the model development lifecycle part, and then the productionization part. There, and the technologies would vary. But if you're dealing with smaller data sets, then it's maybe R and Python is a good place to start. But you're also interested in taking this models to production and be able to deploy it in applications as containers and so forth. Then you'd also be looking at scaling this in Spark and be able to work with high volumes of data because you bring in distributed computing. There's also other pieces to this where you're actually dealing with the production system, where you have to deal with being able to kind of serve the model. So there's also serving layer in model containerization and various other pieces which would come in later. But hopefully that helps. But to the for the data science, pure data science and model development part, it's mostly built on Python, R. We use TensorFlow for deep learning. We use or could be Torch, PyTorch as well. Theano. There's a lot of other deep learning frameworks such as Theano, Cafe, and other things. So it would depend on the problem and the use case we want to tackle. Often Keras is also a part of it. Keras is a simplified, easier version of TensorFlow that also we use. Hopefully that helps. Thank you, Larry.
Great, Ravi. That was very, very helpful. Maxim, I have a question here for you as well, and it has to do with your supply chain optimization case study. And the question says, how would the model include the different shelf layouts, since from one store to another that might vary? Right.
Very good question. Yeah, so this is in fact something that we are we're trying to work out right now. This so again, the idea is that as I've mentioned during the presentation, the particular position on the shelf plays of the slot where the product is to be placed will determine the likelihood of sale of an item, and therefore, of course, the desirability of that spot will also depend on the position, and at the same time, the shelves, like the shelves themselves, they won't be they're not the structure, the shape and the number of sort of layers in the shelf, it's not fixed, right? Of course, going from store to store, you'll have different number of slots per row. You'll have different number of slots per column, and all of these and all of this information we would still like to use to learn from essentially the array of different shelf combinations. And so we're trying to build a model. So we're trying to essentially include this information. And just by the way, of course, we're analyzing the shelf layout with the convolutional networks. We're trying to include that information right now with the assumption that the shelves are sort of essentially uniform grid, but this is not a fixed assumption. This, of course, can be relaxed by essentially resolving the shelf grid more finely as needed. But again, right now we're considering this a simpler structure of the shelves.
Great, great. Thank you, Maxim. Ahmed, I've got a couple here that pertain to your material around the data flow examples that you gave on stream analytics, and a couple of questions. Ravi had earlier talked about our data science life cycle. And there's a question here: how does stream analytics support end-to-end machine learning development life cycle and fit in and complement that? And in particular, there's a related question here for the data preparation and exploratory phase of that life cycle. What is it? What can stream analytics add there as well? And I would direct that one over to you, Ahmed Asadani.
Yeah, thanks, Larry. So Team Analytics supports seamless model building, training, scoring, and performance evaluation by exposing 3 ways of interfaces. You could opt to interact with Visual Studio, a canvas which is very intuitive and have 300 plus ETL and ML operators available for you to draw the pipelines, draw the machine learning pipeline instead of coding it. That's one way of doing it. Another way is interact with the familiar tools like RStudio, VS Code. We support deep integration with them. And third is that platform provides on-demand sandbox environments where you have a complete sandbox machine available for you to do the analysis and then register back your progress with the Steam Analytics, which can be seamlessly integrated with batch and real-time pipelines. So there are multiple ways to skin a cat, and Steam Analytics understands the diversity of tools and requirements in enterprise and supports all of that. And touch base on another part of the question, where how do we support exploratory data analysis? So Stream Analytics is again a unified platform. We support or we have features called dataset, where you could cleanse, prepare, and explore the data from the connections available to you from variety of different sources, and do the feature engineering or exploratory data analysis. So we have a whole dedicated module for that, Larry.
Excellent. Thank you to our panelists for addressing those questions. If you submitted a question and it was not answered here live today, please know that we will send the response to that out to you in email, and we'll share that with everyone who was registered here to attend today. In addition, you may have had, now having seen this material, there may be another colleague in your organization that you would like to have benefited from this that was not available today. And we will have these webinars archived so that you can have access to it after the fact on an on-demand basis. And as I said earlier, you can always reach out to us on inquiry@impetus.com. That closes our event for today. Thank you again to our panelists, and especially to our audience for your time today. I trust you found this extremely helpful, and hope you have a great balance of your day. Thank you for attending.